情報セキュリティの教育機会、教材としての CTF の可能性、ポウンカレッジの試みと日本の現状と題しまして、4名の方にご登壇いただきます。アリゾナ州立大学准教授、オーダー・オブ・ザ・オーバーフローリーダー、ザルダスことヤン・シュシュタイシュビリ様、アリゾナ州立大学博士課程、カナックことコーナー・ネルソン様、香川大学工学部中谷誠様、九州大学セクコン実行委員小出博先生。まずは、CTF の初学者向けに開発されたポンカレッジを開発者のお二人にご紹介いただき、後半では CTF の教育的活用をテーマに質疑応答を行います。こちらのチャンネルはオリジナルの英語のセッションになります。日本語の通訳入り映像はルーム A をご覧ください。それでは皆様よろしくお願いいたします。
SECCON2020電脳会議ご視聴の皆様こんにちは。これからご講演いただくのはアリゾナ州立大学大学准教授のザルダス・ヤン・タッシュビリーさんと同じくアリゾナ州立大学博士課程の学生カナック・コーナー・ネルソンさんです。テーマは情報セキュリティの教育機会、教材としての CTF の可能性、ポンカレッジの試みと日本の現状です。ザルダスさんは現在の DefCon CTF を主催する Ooverflow のリーダーであり、DARPA主催の Cyber Gladn チャレンジでは UC サンタバーバラ大学のシェルフィッシュのリーダーとして3位入賞した実績もお持ちです。今回のテーマであるポンカレッジはザルダスさんとカナックさんが共に開発したもので CTF 初心者が挫折をせずに済むよう実習ができるプラットフォームです。また、ご講演後には、日本で CTF に関わってこられた小出先生で中谷さんにご参加いただき、皆様を代表して、質問をいただきます。それではお呼びしましょう。Please welcome Yan Shoshitaishvili, aka Zardus, and Conor Nelson, aka kanak. Please start whenever you're ready.
Thank you for that awesome introduction, Kana. It's always great to be here virtually or physically. So today we were talking about cybersecurity education, right? This is a topic that is very near and dear to our hearts. Of course, we are educators and hackers and CTFers and researchers and a lot of identities rolled into one. And the core thing for us in our lives is to make sure that all of these different pursuits we're undertaking help build off of each other. And this is exactly where Pwn College came from. Pwn College, as I'll talk about, is a cybersecurity dojo for binary analysis. But first, let's dig into kind of the background, the underlying concepts, the motivation for it, for Pwn College. For the motivation, we can talk about the way that we teach hacking skills right now to actual students. The way that we teach hacking skills is traditionally, we sit people down in front of a classroom and we lecture to them. And we say, okay, this is a buffer overflow. And then maybe they do one buffer overflow and they move on with their lives. Right? They do their buffer overflow assignment and they never have to do a buffer overflow again. Oops, hold on. Okay, minor technical issues, we're back. They never have to do a buffer overflow again. That we have found, I have personally found when I try to teach cybersecurity to students is not a good approach, right? It makes students kind of memorize that there's something called the buffer overflow, and then they learn just enough to pass an exam and then move on. So then you might say, okay, that's fine. We have another technique for teaching cybersecurity. We throw them into capture the flag competitions. So we have students that are interested in cybersecurity. We say, great, you are now a CTF team. Go play SECCON CTF. The problem is that fresh students don't really know what they're doing, and you end up with something similar to this. You end up with a group of CTF players in name, the CTF team that you created of people that don't know security, and they just kind of run around in circles without accomplishing much. And this is extremely frustrating to them. You could say, okay, that's fine. You don't have to start with CTF. You start with war games, right? Offline, level-based cybersecurity education or hacking challenges. The problem with war games is that there's not enough guidance and there's not enough motivation. Students tend to start out. They do a couple of levels of Bandit, a couple of levels of over-the-wire Vortex, maybe the first 2 or 3 levels of pwnable.kr, and then unless they are extremely motivated, extremely self-motivated, and have an extreme amount of resilience, they will kind of fall off the wagon, so to say, and not really go further. And this is kind of the stereotypical, student response to a lot of uncertainty in front of them on a war game level that there's no real, necessity to solve. All right. So how do we fix cybersecurity education? We went back to the drawing board. And of course, cybersecurity education, when we talk about this, we talk about training up not just cybersecurity professionals that will go out into industry and make things safe, but also CTF players that we want to compete in our CTFs, that we want to compete with in other CTFs, et cetera, et cetera. And through a conversation with a number of colleagues at the university, we're from Arizona State University, of course, this idea emerged. What if we approach capture the flag competitions and cybersecurity education like martial arts, right? If you're familiar with the movie Karate Kid, there's actually a very critical movie to the capture the flag community. There's a lot of memes about the Karate Kid. But the core concept is that not all students are the same. And students need to practice. Practice makes perfect to build up their skills. Students start out at a white belt. There are actually 5 stages of education. Sorry, the slide is incorrect. Students start out as white belts. They enter the cybersecurity dojo knowing nothing. Maybe ideally they know x86 assembly from an earlier college course, but they don't know how to exploit buffer overflows, etc. Then they gradually learn cybersecurity to earn their yellow belt. Once they earn their yellow belt, they can begin kind of introductory CTF problems, 100-point problems at kind of the baby pwnables of easy CTFs. After a bit more education, they achieve their blue belt. Now they can approach kind of 200-level problems. Then brown belt, past that, and then black belts when they've achieved true mastery. The black belts of cybersecurity go to Pwn to Own to win Teslas or play DefCon finals. That might be a self-serving view to fight for black badges at DefCon CTF. But then we realized, okay, different steps of the CTF, of the cybersecurity knowledge journey require different approaches for learning, right? To get a student into the dojo, to get a student their white belt, we use traditional cybersecurity classes, stuff like computer organization, programming languages, operating systems. These teach them the basics that they need to approach security. Then they have their white belt. And then we don't have a good way to teach them enough for them to acquire their yellow belt. We don't have a good way to teach them to acquire their blue belt. Once they have their blue belt, they can use war games to build up their knowledge and CTFs to solidify and learn on the fly and master concepts. And then once they have their brown belt from that, They can use CTFs to develop advanced knowledge in cybersecurity and war games as continued practice to achieve black belt. But these first two stages are missing. And we again thought back to practice makes perfect, the other tenet of any sort of martial art education, right? I took Taekwondo as a when I was in school, and the amount of time that we practiced blocks, practiced kicks was extreme, but it was all necessary in order to achieve perfection in the art. So we realized, like in Karate Kid, wax on, wax off. We needed a resource that had a gradual learning curve, so it didn't scare away students, allowed them to repeatedly train their techniques, offered guidance as they tackled harder and harder concepts, and had built-in motivation to ensure that they kept pushing. Oops. And that, of course, platform, that tool, the class that we created is called pwn College. All right. pwn College is a course at Arizona State University that turns white belts that don't know how to read in data with bin cat, for example, into blue belts. People that can tackle the exploitation of T-cache weaknesses or heap weaknesses by exploiting T-cache, that can approach kernel exploitation, that can reason about complex implications of memory layouts in the context of race conditions, all of these complex things. And we cram all of this into one semester. And we have that gradual learning curve. We have the repetition. We have the guidance. We have the motivation. And it's not just a course at ASU. Taking advantage of the fact that all education is currently virtual, we've made ASU's cybersecurity course, computer system security, pwn College, available to the world, to you. pwn.college is an actual URL that you can go to where we have pre-recorded lectures and our practice problems. All right. So how does this course work? The course is split into several modules, right? Modules that you tackle one concept at a time, with several modules to put multiple concepts together. Every module has YouTube lectures that we've pre-recorded that are available to teach you the basics. We, over the course of the semester, we did Twitch office hours and Q&A sessions. Twitch is a video streaming site for live streaming. That was during the semester. Outside of the semester, the semester that ASU computer system security runs during is from August to December, so that just ended. But in the future, we're thinking of doing one live session every couple of weeks just to answer questions that have piled up from the general public and so forth. We have, and most importantly, we have a large set of challenges. Right now, we go through a number of modules to convey, to teach a lot of different cybersecurity concepts. We start from program abuse, just the abuse of SecUID software. Then we talk about shell coding, sandboxing, reverse engineering, memory errors, and we have a module that ties all of that together for an end-to-end exploitation lesson with many, many examples. At the completion of this, we consider students as having earned their yellow belts. And this isn't just a conceptual concept, right? It's not just an entry on a website, although we do have a part of pwn College, pwn.college/belts, where you can actually see who earned their yellow belt. We also send students a physical yellow belt with pwn College embroidered on them that they can wear to conferences if they want, hang on their wall. It's a token that shows that you understand basic exploitation concepts, and then we go advanced. The yellow belt to blue belt curriculum covers advanced topics such as return-oriented programming, heap exploitation, race conditions, kernel exploitation, and then an advanced end-to-end exploitation pipeline where you practice breaking through user space applications that are sandboxed, similar to a modern web browser, and attacking a vulnerable kernel module to escape out of SECCOM sandboxes, for example, among other concepts. And then we dive into automated vulnerability discovery, fuzzing, symbolic execution, these sort of concepts that are now on the cutting edge, on the kind of the research edge. And after completing all of these, a student earns their blue belt. And again, alongside an entry on the website where we have the list of everyone that has earned their blue belts and yellow belts, you receive a physical blue belt, showing that you are at a certain level in cybersecurity. All right. Talked about gradual learning curve. Of course, this isn't just on the concept of whole modules. Also within a module, we need gradual learning curves. Every module comes with a large set of challenges, right? And these challenges are split into levels. So for example, our shell coding module might have 10 levels. One is just write shellcode. Two is write shellcode, but it's at a random position on the stack. So the shellcode has to be position independent. This isn't hard with modern processors, of course. x86, 64, more or less everything is position independent by default, but it's a small step. And then we introduce various constraints to slowly complicate the problem so that students explore different aspects of shellcoding. Shellcoding when you cannot send certain bytes. Shellcoding when there are certain operations performed on your shellcode, etc. Over the course of these levels, students reach more and more conceptual complexity with each module. And this is the true way that they master the individual concepts, not just in lectures. The lectures provide the base for which to approach the challenge problems. And then the challenge problems push the students step by step. In fact, these challenge problems have the challenge problems are designed to really explore every concept. For every level, for example, where possible, it's not always possible, but where possible, every level of every module has multiple variants. So every student will receive 3 levels. For example, let's talk about memory corruption and the performing of a buffer overflow. Every student will receive 3 levels, where in each level, the buffer is a different size. Every student for every level might receive 3 challenge problems, where in a given level, with a given buffer that has to be overflowed to overwrite the return address of a function, that buffer is a different size. This this is designed to force students to truly learn how to do, for example, buffer calculations, memory offset calculations, how to really think about the state of memory, the steps they have to take to solve a problem, not just once, but multiple times, to repeat and really build it in to the base of their psyche. Again, it's wax on, wax off. You don't practice a block or a kick once. You practice it over and over and over and over again. By the end of every module, by the end of the class, we want these students to be able to perform buffer overflows in their nightmares. That's what I always tell the students when they complain that there's a lot of practice problems. An interesting side effect from this, because we have to differentiate multiple instances of challenges with different buffer sizes and so forth, every student gets unique challenges as opposed to every other student. So it the potential for cheating, but also it reduces the temptation of cheating. And instead, we encourage students to collaborate on the conceptual level. So they collaborate on the concepts that they need to learn, and then they can apply these concepts separately to their individualized challenges. All right. Guidance. We talked about the need for guidance to guide white belts through their journey, through their yellow belt, through their blue belt. Of course, the problem is each of these concepts is extremely, extremely deep. It's very easy to teach an entire semester on shell coding or any other concept in pwn college. Every week for a normal ASU course, we have 3 hours of lecture. It is not possible to teach on all the concepts necessary in 3 hours. So what do? We created something called a teaching challenge. It is a challenge that holds a student's hand through its own solution, that teaches them the concepts as the students do the challenge. A good example is a memory corruption challenge that tells the student, hey, the buffer is this size, and here are the calculations you need to make, and here's what the result should be. And then when the student tries to overflow the buffer, the challenge says, okay, now you've overflowed the buffer by this amount. This is what was written over the saved base pointer. This is what is written over the saved return address. This is the state of memory at this time. And now this is what will happen when the function returns. One variant of every level that we create is a teaching level to make sure that the students get this. And later we'll have a demo where Connor will show what this really looks like. All right. And then, of course, we want students to be able to practice. We don't want to just throw them into a complex environment where they have to exploit a program and not give them the tools to figure out why their exploits fail. So there's another innovation we created where every challenge can be started up in a practice mode. In practice mode, you have root access. That means you can debug the challenge fully. You can launch it with GDB or whatever debugging capabilities are relevant to the specific challenge. You can trace its system calls. You can do everything. But of course, there's a fake flag for the students to retrieve. They can't actually solve that in the challenge in practice mode, but they can write their scripts. They can write the solution in practice mode and then restart the challenge in normal mode to solve it. The awesome thing, our infrastructure has a persistent home directory. Students can save their work between challenges, between practice and real mode, between teaching and testing challenges. So they can create their solutions, debug them, and then reboot the challenge in real mode, run it, and solve it outright. Cool. And of course, motivation, we made it very easy. We have every practice problem. When you solve it successfully, you can get a flag, whether that's because you find the right password and the program gives you a flag, or you exploit the program to giving you a flag. And there are no exams, there are no quizzes, there are no group projects, there are just flags. That's the only thing that we grade on. And the incredible thing is, even outside of ASU, for students who don't have their grades dependent on their performance in pwn college, they're motivated by these timed graded modules, which is incredible to see. And students really take it very seriously. There's a scoreboard, shows who's doing how well, and they really try hard to push to the top of that scoreboard. And of course, there's the motivation of the belts. The motivation that if they solve 100% of the first 6 module challenges, they can get a yellow belt. If they solve all the challenges in the whole course, they can get that blue belt. And they're pushing beyond the requirements of the course to get those belts. All right. Of course, the disclaimer here before we go on to bragging and demos is the course is for white belts. if you are already playing capture the flag competitions and etc., doing well, this course is not designed for you. If you're already a blue belt, it's going to be very easy, possibly very boring. It's going to be very trivial for a brown belt. It's going to put black belts to sleep. This is not a weakness of the course. This is intended. The course is for white belts to train them up in the cybersecurity dojo to allow them to approach complex cybersecurity problems. All right. As part of this training, the students tackled some significantly tricky challenges. In the reversing module, I created an architecture called Yan 85 that the final level had them reversing blindly with a randomized instruction set for the architecture. In the first end-to-end exploitation module, they exploited a JIT spray on a JITted Yan 85 emulator, right? An actual JIT spray attack, similar to something that you might see inside a browser. They did ROP under extremely information restriction scenarios, full PIE, full ASLR, and so forth, nearly blind against network servers. And they performed an end-to-end exploitation of a sandboxed application and a seccomp escape through the kernel as part of the advanced exploitation module. These are serious challenges, and students approached them who had no concept of what a buffer was at the beginning of the course, which is super, super cool to see, and we were very proud of seeing that. We also encourage CTF. This is an important part of cybersecurity education. It's that practice from blue belt to brown belt involves war games and CTFs. We allow students to earn extra credit every weekend by playing CTFs. 1% of their final grade every weekend. And this motivation caused 3 CTF teams to be created. And this semester from ASU alone, who have been playing every weekend, trying to get flags in increasingly hard CTFs and steadily getting better and better at it. And this has been incredible to see. I don't think I, myself as a CTF educator, has ever had as much success getting people into CTF as I have with this course, with this incentive. And of course, it is all for about practice makes perfect and this gradual learning curve to push people through the cybersecurity dojo. Wax on, wax off. All right. So how did people do? Well, anecdotally, people report a humongous workload, typically around 40 hours per week. This is way too high for a single class. We're trying to figure out ways, can be turned into 2 classes, where one class gets you the yellow belt, one class gets you the blue belt, etc. Students overall loved this course. They rate it super highly. They clamor for Connor and I to get raises. It's very awesome to see their enthusiasm, and we've presented this concept at HitCon and Code Blue and now SECCON. So this is a very, very in-demand concept that I think is a good way to go. The ethos we're following, of course, release early, release often. We actually had a version of pwn.college up and available kind of quietly since January. In August, we very publicly launched it to the entire world because we were ready for students from outside of ASU to learn alongside ASU students this semester. And we're continuing to improve it. So on that note, I'm going to hand the stage over to Connor, and he will show a demo of the current state and awesomeness of pwn.college. Connor, take it away.
All right, awesome. Let me go ahead and share my screen here. Let's see here. Can you see my screen?
Yep.
All right, awesome. So this is the pwn.college site when you first go to pwn.college, and as Yan said, that is a real domain. There's a whole bunch of information on this site, including where you can find the lecture videos as well as the Discord. But the thing that we're most interested in right now is the infrastructure with the challenges. So this will bring you to the hosted challenges for pwn.college, where you can see all sorts of things. So we'll start by taking a quick look at the scoreboard to give a brief shout out to all the amazing hackers in the class as they fight their way to get their yellow belts and blue belts. So we can see here that as of the recording of this, that 6 people have actually earned their blue belts, and we have you can see a whole cluster of actual non-ASU students that are very close as well to earning their blue belts, which was really awesome to see. Okay, so now if we click on the challenges tab, we can see all of the levels that are available, and there is a lot for all of the modules. I think the easiest thing to demonstrate, since we've been talking about kind of basic buffer overflows, is going to be the baby mem module, where you can kind of see and get a feel for what these teaching levels are all about. So I will start by demoing level 1, teaching 1 of baby mem. So we can see that when we click on it, there's a bunch of options. We can actually inspect it and view it in Binary Ninja Cloud. We can download it. And then we have the 2 options of running the challenge and kind of practicing the challenge, putting it in practice mode with the fake flag. So we'll start by just running the challenge. And after a couple seconds here, we should see a message telling us we're ready. Okay, so now you can SSH in, or alternatively, you can actually view the challenge in your web browser, which is what we'll do for this demo. So if we click now on the terminal tab at the top, we are presented with a terminal. And if we take a look at the root directory, we can see that we have this suid binary, which is our challenge binary, that is going to become root once it is executing. And then we also have this flag file, which is only readable by root. So of course, the goal is to make this binary read the flag. So if we launch this challenge up, we will be presented with a whole bunch of information since this is a teaching challenge. We actually have the challenge set up where it will actually print out its entire stack, or the stack frame of main, or I guess in this case, vuln, showing all of the local variables and pointers and everything going on the stack. It tells us a bunch of addresses that are available here. It tells us, for instance, that we have this input buffer that begins at this address, which is partway through the stack frame. It tells us that that buffer is 82 bytes long, but the program will let you provide an arbitrarily large input, since this is kind of the first level of baby mem. You might, if you've seen this sort of thing, it's kind of, I guess, the most introductory sort of buffer overflow you can have. So we have in this challenge, there's this win variable. By default, it is 0. However, if the variable is non-zero, the flag will be printed out. So the goal is basically to escape through this input buffer. Oops, that was accidentally clicked the wrong thing. Let me click on that again and launch. We can see there's this win variable, and the goal is basically to make it non-zero. So we know that we're allowed to send 84 bytes. So for instance, if we send, let's say 20, and we'll just send some random number of A's here, we will see here that then when the program is exiting, it'll actually also print its stack again to us. And here we can see all of those A's living in memory. And it reports to us that the most important thing, I guess, in the case of this challenge, is that the value of the win variable is still 0. So the question then is, how do we make it be non-zero? And as you might be expecting, the goal is to write more A's than the buffer really was willing to accept. So if we instead make the payload size, say, be 120 and send a bunch of A's, we'll just kind of hold the A button down for a few seconds, and hopefully we'll send more than 84.
And Connor, while you're holding the A button down, I'll hop in and I'll say, you you see that this program is printing out its own memory space and stuff. This is, of course, what someone can do with GDB, but a lot of the students, the white belts, they're not used to doing everything in GDB, to debugging, to understand. This is a crutch to help them along, and we slowly reduce this sort of information until they're forced to use GDB, especially on the teaching challenges and so forth.
Yeah, exactly. So now we can see, after we finally sent a bunch of A's manually here, that we've just completely crushed right through this stack. All that it's printing to us is just a bunch of A's. In fact, at the end, it actually tells us stack smashing detected, which will be a concept that gets explored in a later level. And it tells us that the value of the win variable is a bunch of A's printed in hex for ASCII. And then, of course, it tells us now that we've changed our win variable from being to be non-zero, that out comes the flag. So going along with that idea of this is the teaching level, if we look at that same level but as a testing variant, which we can see here. So that was the teaching. If we look at level 1 testing 1, and there's a level 1 testing 2 as well. But if we take a look at level 1 testing 1 and launch it, we're going to see a very different amount of output, let's say. So if we launch it up, it just immediately says, what's the payload size you want? Send me your payload, and we send a bunch of A's or whatever. And that's it. It doesn't actually print its stack to us. So this is where you would need to go in and actually launch the challenge up with GDB or whatever debugging tool you want to use to try and understand what are the offsets, where is this buffer located, how far away is the win variable from that. And you can kind of reference the teaching variant to understand what information is useful, and then maybe try and figure out how you can start finding that information for yourself using GDB. Yeah, so I guess another interesting thing to show might be baby kernel level 1. And I'll show baby kernel level 1 because that's maybe, in my mind, one of the most obvious places where we're going to want to start showing off what practice is all about, though it's definitely useful in several of these modules. But if we actually run baby kernel in practice mode, we will see the power that practice mode provides. So if we go into the terminal, so the thing with practice mode is that now I have the ability to sudo commands. I'm part of the sudo group. So if I sudo ls, sudo who am I can run things as root. So this makes it a lot easier for the kernel challenges, where we actually have this launch binary that will start up QEMU, an emulator, and basically emulate a whole system for us for this challenge, since it's a kernel challenge. So if let's start by actually running tmux so you can see what I'm about to do. If we type /launch, we will see the emulated environment start up in QEMU, a whole bunch of initialization information, and now we are into our environment. And the thing to note also is that the home directory is mapped in here, so you can kind of transfer data back and forth for that in a way that's potentially a lot easier than having to like base 64 encode your data and like figure out how you're gonna put it in there.
Traditionally, teaching security in the kernel and making CTF challenges about security in the kernel has been a gigantic pain because, like Connor said, you have to like copy paste your exploit binary over a network connection. Sometimes it has to be statically linked. It's a nightmare, but this allows students to not suffer and then approach this trying to exploit the kernel directly in this emulator environment.
Yeah, exactly. So we can see that here in this level 1 challenge that, again, we have a flag that's been mapped in, readable only by root, and that we have this pwn.college kernel device that's available to us that we're able to start interacting with. And since we're in practice mode, there's this really cool feature that QEMU provides that allows you to basically connect up with GDB. So if we run GDB now and do target remotes :1234, it will actually allow us to just start debugging the kernel. We can basically step through syscalls, step through all of the kernel code that's happening in this level, which in the case of kernel, right, where maybe sometimes it's kind of difficult to debug what's going on because now it's in the kernel, you're able to do it, and you're able to do it in practice mode, and basically just step through it as you would in any other module, which is pretty awesome, I think. Do you have anything else to add to that, Yan?
I think other than doing the modules this way, other than being helpful for solving the challenges, rather, it's always so super helpful for teaching, especially this in practice mode. During my lecture on the kernel, I actually launched up a challenge in practice mode, created a Hello World program, and in GDB showed them that step between the syscall instruction in user space and the kernel syscall handler. And that, I think, was kind of an eye-opening experience for students, seeing that, code just keeps executing. There's nothing magical. It's all super, it's very cool, but it's not a mystery anymore. That was very cool.
Yeah, I think a lot of students were, after spending multiple weeks staring at things in GDB and always being able to just step over this magical syscall instruction, suddenly typing like SI and it just entering the kernel is kind of a crazy experience.
Yeah, and I want to stress again, these are students that 2 months before this moment, some of them hadn't ever seen x86 assembly. And now they're exploiting, writing shellcode that'll run in the kernel to give them root access.
Yeah. All right. Is there anything else you think I should demo, or I think that kind of covers?
I think that's it. Let's roll on with the rest of my presentation. All right. So we did the demo. All right, one thing that we're doing, which is I'm pretty excited about, but we are it's a bit of an experiment. We're offering free private instances to educational institutions. So if you are a university, a high school, and you want a private instance of Pwn College for your students to play around with, you can. In fact, it's not just the challenge problems, it's also all the lectures, everything. We license all the lecture slides and so on under Creative Commons so that you can actually use this as a turnkey cybersecurity education course. So if you're interested in that, shoot us an email, let's talk. And again, for educational institutions, we'll just add an extra subdomain to point to the server that's already running this stuff anyways. So I'm happy to provide that for free. All right. Can we take Pwn College into the third dimension? So we have this kind of Pwn College dives deep through individual concepts, shell coding, jailbreaking, with sandbox technologies, reverse engineering, and then covers a lot of these concepts, but they all go in the direction of binary exploitation because I really like binary exploitation. And so does Connor is much more general. So he's been, of course, interested in, hey, can we scale this out? And our hunch is yes. There's nothing preventing us from making a web security course in the style of Pwn College, or with additional modules in Pwn College, crypto modules, forensics modules, things that take students step by step through the development of various concepts. So this is definitely something on our radar. We are thinking about doing this to expand ASU's cybersecurity curriculum, for example. Pretty excited about things that we might hopefully have some time to develop in the future. All right. Do you want to help us develop it? You can. Pwn College is partially open source, so the core infrastructure is open source. The modules themselves are not open. These are used to assign grades, real grades with real life implications to students. So we don't have them just up on GitHub. However, if you are a trusted educator and you would like to collaborate on the creation of, for example, web security modules and so forth, reach out. We're very happy to talk and actually collaborate on the actual challenge problems as well. All right. We're always open to visitors when it's not COVID time, but hopefully we will be over this whole virtual situation soon. We hope to come talk to you at SECCON in person next year, and we hope that you come visit us at ASU and we'll sit down and hack. Otherwise, we are Yan and Connor, and it's been a privilege to talk to you.
Hi. Thank you for very exciting presentation. My student who supervise interest in PWN college, I think she will email to have an instance. That's okay.
Awesome.
Yeah.
Perfect.
And I have a question. In what grade do students take this course?
That's an excellent question. So this course is in the ASU curriculum, placed senior year. So their fourth year of college, right before they graduate.
I see. Then have the student learned the computer science basic course like programming or, for example, data structure?
Mm-hmm. Yeah. So those are maybe on the second year of their university of their college progress. We definitely have a ways to go to make sure that the students that enter the cybersecurity dojo have the necessary background. There are some concepts that students forget between taking computer organization in their second year, or data structures, or programming languages, or operating systems, and between when PWN college starts. There are some concepts that they don't necessarily learn in operating systems, right? So there's definitely a good point. Like it's very tricky. There's that distance between the learning the fundamental concepts and then really going to war with them in PWN college.
And do students who try a lot of challenges have good result or not? I want to know the relations between challenges and result of the class.
Yeah, so it's a little tricky for us, of course, as kind of professionals in the area, to create challenges that are just hard enough to teach students something, but not so hard as to discourage them, right? And we don't always succeed. Actually, Connor, do you still have the PWN college pulled up? Is it? Yeah, let's bring up, for example, Baby Rop. Connor will show that we have these massive drops with where there's one level where 100 people have solved it, and the next level only 50. Right, and this is what we want to avoid, because this means that the conceptual gap that we try to bring the students across was too wide. So I think ROP and maybe race is a good one. Let's see.
Looks like we're still over 100 here. And then
ROP,
there's a jump there from like 8 to 9 where
a
bunch of people suddenly fall off.
So how much is 8?
So 8 has 107 solves, and then 9 suddenly has 66 solves.
So there's some concept that we thought was very straightforward for the students. It's straightforward enough to just make it a single level.
Yes.
But the students, almost half of the students were unable to actually follow us to develop that concept. And this is despite the presence of teaching challenges, right? Which often straight up tell them what the concept is. So that's definitely a, I guess to answer your question, the way that we figure out what what the right step is trial and error, unfortunately. We try. Last year, for example, before this, I think how many levels did we have, Connor and Baby Rop? 8?
Yeah, I think we had 8.
Yeah, so I think last year we had 8, so we've padded them out. So now we have 15. So there's, if you cover the same distance, that's smaller steps, but there's still too wide a step between 8 and 9. So next year we'll probably have, 18. Yeah.
Yeah, it's like a good environment to see where people get stuck so that we can just introduce the necessary things to make them not get stuck the next year. So every year it'll just continue to improve.
Mm-hmm.
Okay.
Hi, thank you for your awesome presentation. I wanted such like this college when I was young. Okay, I have some questions. I think the yellow belt is a little bit harder for college students. I think. How do you think?
Yeah, so a yellow belt versus a blue belt, right? This is a good question. Again, we can look at the numbers, right? And in fact, we have these numbers and they're scary. We started the class this year with 209 students, right? It's a large class, but that's because I took off the maximum. There was no cap because it was virtual anyways, right? There's no room that people have to fit into. So I said, okay, any amount of class. So that's just ASU students. I don't have the numbers, unfortunately, for the worldwide students, how many were serious and so forth. So we have in the very beginning a sort of weed out assignment. The first module, the set UID misuse right now is really structured to separate the students that are serious about this. I can look up real quick how many students we had.
Also, just for some data, so we currently have 24 yellow belts, and 14 of them are from ASU and 10 are from the rest of the world.
Yeah, and so basically out of this 209 students, I'm going to pull a number out of my head just off of memory. I think we had about 150 that remained after the first week. So these are serious students that have entered the dojo. From those 150, you said 15 are from ASU, Connor?
Yeah, so 14 of them. 14.
So from 150 so far, and there's still time in the semester. They have until December 14th really to solve challenges. And plus, they can earn their yellow belts later. But in the bounds of the semester, less than 10% have made it to yellow belt. Of those, Connor, how many have made it to blue belt?
We currently have 6 blue belts.
Yeah, and so that's a subset of the 14, right?
Correct.
Yeah, and so of those, almost half have made it to blue belt. So I absolutely agree with you. Yellow belt is harder. Right now, we are thinking about, which is actually an interesting thing, because everyone would say, okay, yeah, but exploiting kernel bugs to escape from SECCON, that's got to be harder, right, than a trivial buffer overflow. But it's it's like friction. Static friction is higher than dynamic friction, right? Once an object is moving, it's easier to keep it moving. It's getting people, like you said, to that yellow belt. That's super hard. So next year we're exploring other concepts. So for example, we're thinking you could have, like I mentioned, one class that takes people. So 466 takes people through the yellow belt, and we just maybe with some extra concepts, maybe with some extra background, maybe we move basic kernel exploitation into the yellow belt and advanced kernel exploitation in the blue belt. But they have the whole semester to do just the yellow belt. And then we have another class, maybe 566 or something, right? The next step where we go deeper. It's hard to. So we're speculating and trying to brainstorm a number of things, but I absolutely agree with you. Yellow belt is a grueling task.
Thank you.
Yeah. So actually, I have a question for you, if that's okay. This style of education that we're trying with PWN College, it's I don't want to say like unique in the U.S., but it is not the typical cybersecurity education design, right? There are other courses based around challenge problems, et cetera, but I think it's unique in how it's structured and so on, right? Or at least, not super common. And I've talked to colleagues in Europe, and they say, whoa, this just sounds like, first of all, way too much work for the students. They might have a point there. But second of all, it's very different than how they approach cybersecurity education there as well. How does this compare to the Japanese cybersecurity education?
I see. I think your trial is very unique. But in Japan, many CTF contests are held for university students. For example, in addition, for example, Kyushu University has been developing cybersecurity education course for professional engineers. And we put a CTF contest competition at the end of the course. But in your case, mainly it's CTF, I think. And yes, students changing CTF very hard.
Yeah.
Yes. And my experience, I think CTF is also effective, and even professional engineers, not only students, but also engineers, I think. And
yeah, it's interesting. So Japan has a lot of local CTFs, right?
Yes.
Yeah, that is very unique. It's something that we don't see in the U.S. There are some. So there's local CTF held in New England, right? That where the universities that are like in New York, Massachusetts, that area, they'll gather and play. But that's about it actually for local CTFs, which is very unfortunate. I think Japan is very unique in that. And I've been trying to think of why this is. Part of it is, we're in Arizona. If you want to go anywhere, it's, if there was a CTF held in San Francisco, that's like a 17-hour drive or something, right? So it's a bit far. There's no regional CTF that can happen out here. In New England, I think that's why they have a regional CTF. And maybe there's some I'm not aware of, by the way, regionals as well. But I think that's just one thing. I think another thing is the early stage education that you mentioned before cybersecurity. I think it's different. I think my feeling from talking to CTF players in Japan, and this is actually a question, if you agree with me or not, is that the fundamentals that they are taught prepare them well for CTF.
Yes, I think possible.
Yeah.
If we make content for fundamental computer science, I think we can apply CTF method to the fundamental educational computer science course, I think.
Yeah. That I think is a very key difference. I think and I'm not quite sure what the problem is. What the difference is really with the American fundamental education of of computer science. But for whatever reason, when students enter my course, they're not quite as prepared as my feeling for the Japanese cybersecurity education curriculum.
That's maybe resembled to game. Yes, computer game. Yes, and I think almost all students like computer game. Yes.
Yeah. That's true. Gamification of security is definitely a good path forward. I think it gives them that motivation to learn, of course. Connor, what do you think? Is that jive with your perceptions?
Yeah, I think I remember the first computer security course I took at ASU with Adam, another professor in our lab. That was just the thing that hooked me on security, was the gamification of it. So he had some CTF challenges in his course, and I remember just like fighting to go to the top of the scoreboard was just like extremely motivating for trying to learn stuff.
Yeah, it's I am very jealous of the awesome kind of local CTF culture.
Yes, by the way, do you have any bad influence for COVID-19 pandemic at your class in your university?
So ASU's been super. So basically, our spring break happened when kind of the first wave hit, right, at ASU, and they made the right decision to basically go virtual after spring break. They said there are just no in-person classes after spring break. For this past semester, for August, the administration said, okay, any large class, more than a handful of people, is going to be fully virtual, right? Other classes will be optionally virtual or in person, but with every student should be able to go fully virtual and still succeed, right? And so this is why we took our class virtual for this year, and then at first it was like, okay, well, we're going to have to do a lot of work and all of these lectures that has to be recorded, and how are the students going to learn over Zoom? But this turned out to be a massive opportunity, right? And I can't stress enough how much adversity. It's kind of like in the concept of CTF, right? You make people learn and make people develop their skills by giving them challenges, right? So we were given the challenge: move computer system security fully online, right? And the way that we addressed that was an online, fully scalable infrastructure, pre-recorded YouTube lectures, utilized gaming platforms. Twitch is a platform for gamers, right, to stream video games, and we're using this to stream classes. And it turns out students love this. We were able to cover more this year in computer system security than we were able to do last year. Not just because no one is traveling, so we don't have to cancel as many classes and so forth, but also because the videos that are pre-recorded, people can go back and view them very easily. They can.
Students want to stay at home.
Yes. Exactly, and we adapted. For this sort of communication of the course now, instead of a mailing list, which we used before, we have a Discord channel. Again, a platform for gamers. I realized this semester that video game players have long built communities over the internet and maintained communities and taught each other how to play and so forth over the internet. And we're just kind of catching up in the cybersecurity education world. So I think COVID was a challenge, but it triggered innovations that allowed us to not only remove the cap on the class, like I mentioned at ASU, but to open it up to the world, right? And I actually think this should be the democratization of cybersecurity education, right? This is what it is, and we should keep it going beyond COVID. It's not easy, right? To revamp the course in this way. I think Connor and I lost maybe 2 or 3 nights of sleep a week. It was an insane semester, but I think it's the right thing to do. And I'm hopeful that post-COVID, we'll be in a fundamentally different place in cybersecurity education, where anyone can go online and not just get all the data they need, because that information has always been there if you are, dedicated enough, but be guided in a classroom setting from the comfort of their home.
I see. I think your trial is good at classes after COVID-19 pandemic.
Yeah. Exactly. Yeah, absolutely. So that's one thing that we're looking at in the future. Home college is already bigger than we can cover in a single semester in a single course, right? So we're going to split it into multiple courses, most likely. While we're doing that anyways, we can, of course, create a set of web modules or crypto modules, etc. Our original concept for Pwn College, actually, we were going to have a web module. We were going to have a content injection module where we talk about command line injection, talk about, cross-site scripting, this sort of thing. That's still very much on the radar. It's a matter of what course to put it into, and what, just exactly what type of module this will be. I think we can cover, for example, content injection in one module. We can cover input validation errors in another module, and so on, and move on. Rebinding attacks, these sort of things. It's definitely on our radar. I think as we continue to kind of revolutionize ASU cybersecurity education curriculum, we will bring in more and more people and so forth. Probably, for example, the correct person to create a web track of Pwn College would be Adam Dupay, another professor at ASU here, fellow DefCon organizer as well. So I think our different, Connor, do you want to talk about your?
Yeah, I can go first. Yeah, so you can finish us out. So I think the reason that I really enjoy CTF is that it just forces you to learn things in this just like hyper competitive, super fun way. So I think it's the thing that really keeps me going to CTFs like every weekend, just constantly hammering them out, losing countless hours of sleep, spending 40 hours over the course of 2 days just playing a CTF, is that it requires you to just sit down and deeply and truly understand something. And I don't know, there's just nothing in my mind that's there's nothing that in my mind that compares with CTF that gives you the opportunity in that way to just truly, in like the deepest sense, understand a concept. And in this competitive environment just makes it all the better. Yeah.
Hey, thank you, Connor.
Yeah, and I approach CTF and actually computer science from a very philosophical angle. Connor said that deeply understanding something is incredible. I've talked to people before that say, okay, they might not want to understand how something works because then it's less magical. For me, the understanding of something at a very deep level is what makes it magical, right? Understanding how computing works, how certain CTF concepts, how certain concepts that CTF explore work, is what really motivates me about cybersecurity, right? And what I love about cybersecurity is it forces you to operate on the underlying level of everything that you touch. That means it forces you to understand perfectly the underpinnings of everything that you touch, right? And as I said, understanding something makes it more magical, right? So if you want to truly experience the web, you have to understand how the web works on a low level lower than the web actually functions. You have to understand how the browser works. You have to understand how protocols work. To truly understand those, you have to understand how networking works. Understand how all of these concepts are related. That to me is why I push forward in cybersecurity education, because I might have never experienced this if I hadn't gotten hooked, not just on that book that my grandma got me, but also RPI's computer organization class, which instead of some dry, boring theoretical stuff, had us targeting hacking challenges in x86 assembly. It has been an honor being virtually here. Next year, we'll come visit in person. Maybe we'll have new developments in pwn College. But go earn your belts, and we'll bring them with us.
Thank you all for taking time out of your busy schedule to be part of SECCON 2020 today. It was a grateful meeting, a grateful presentation. And thank you again to Mr. Zardus, Mr. Kanak, Mr. Nakaya, and Koide Sensei for today. And thank you everybody for watching. Enjoy the rest of the SECCON 2020 電脳会議. Bye now!
皆様ありがとうございました。